We're starting the second unit and we're looking at mechanical systems. The first thing we're going to look at when we look at mechanical systems is we're going to look at friction. When you think about it, friction plays a large role in mechanical systems. If you look at an engine and you look at engine oil and its role of lubricating to get rid of friction, that's just one example, but it is the idea of where friction is important. Now, to understand friction, we have to go back and go over a couple of things. We're going to end up doing two problems, and they're going to be the meat of what you have to understand for friction. The first thing you have to understand is force of gravity. If we have the Earth and we have a person above the Earth, they are being, and I'm going to use the word attracted to the Earth, with a force of gravity of 9.8 meters per second squared. Now it's negative because they're going down, so negative is a direction. Now, what Newtonian physics does is it explains mathematical relationships. It doesn't say how gravity works. So if I took you up in a plane and I pushed you out, you know you'd fall, but it doesn't explain why you're falling. But what Newtonian physics tells us is the greater the mass of the planet, the greater the gravity we're going to have. Heck, even your head has a gravitational pull. Because your head has mass, it will attract dust particles around it. Now, you don't have a very strong gravitational pull, but you do have a gravitational pull. The other thing is distance. The further away an object is, the less the gravitational pull is. So that's described in Newtonian physics. Now, in Einstein's world of physics, he tried to explain why things happen. So if you're interested, he talks about something called the space-time continuum, and he tries to explain why gravity occurs. So Einstein was able to predict the presence of black holes by using his space-time continuum. What you have to remember with any force, whether it's gravity or anything else, is force is equal to the mass of an object times acceleration. If we are going to talk about gravity, it is 9.8 meters per second squared. Now, this whole idea of the force of gravity is going to come into play later on when we get into tying everything together with friction. Okay, another thing we have to get straight is mass versus weight. Mass and weight are not the same thing, although they do get used interchangeably in our society. If you have a mass of 70 kilograms, weight is talking about the force. So that would be your mass times acceleration due to gravity, which would be 70 times 9.8. And if you give me a second, I'll do that calculation here. So your weight would be 686 newtons. So just remember, if you hear the term weight in physics, that's going to be measured in newtons, where mass, which is the amount of material in an object, is measured in kilograms. So when you step on a scale at home, what we're talking about is mass. It seems like we've got two disparate ideas here, but we are going to tie everything together as we get into friction. Now, when we talk about friction, friction can be good and it can be bad. We don't want to have too much friction in our engine when we're driving, because then our engine could seize up and we lack performance. But friction could be good with shoes because it can give you grip. So remember that as we're going through things. As we're developing towards point number 5, which is our final point, let's talk about static and kinetic friction. If we have a box and you are trying to push that box, to get that box started, that's static friction. And static friction is always high. It's harder to get the box moving than it is to keep it moving. So kinetic friction is when we get moving. I want you to remember one thing. Static friction is getting something started to move. So static means stationary. And this is always higher than kinetic friction, which is the friction of movement. So when physicists talk about friction, they will either state whether what we're looking at is the static friction or the kinetic friction. This brings us to our formulas, and this is what you have to understand from U2A1. So what we have is a formula that states the force of static friction is equal to the coefficient of static friction times the normal force. And we're going to review what normal force is in a minute. We could also say the force of kinetic friction equals the coefficient of kinetic friction times the normal force. Now, what I'm going to do right now is I'm only going to focus on this. The formulas are the same, but what you have to understand from what I said earlier, this is when we're moving, this is when we're getting started. Now, we can rearrange this formula to figure out what the coefficient of static friction is. It's the force of static friction over the normal force. Now, let's talk about what the coefficient of static friction is. It's how, let's say, how sticky a surface is. So I'm going to use that term, sticky. And it's like a scale from 0.1, which is low, to 0.99, which is high. You can actually go greater than 1, believe it or not, but those are rare situations. So we're going to say it's like a scale of 0.1 to 0.9, 0.1 being slippery like an ice surface, 0.99 being like sneakers on pavement, you know, it's a little higher. Well, that might be closer to 0.7, but anyways. What we have to do is figure out what all of the different things are in here. So we're going to use that first formula, and we're going to find the force of static friction as somebody is pushing a brick along a surface. So we say the coefficient of friction times the normal force will tell us the force of friction. The coefficient of friction is 0.6. That's given. That means it's a pretty sticky surface. To get the normal force is the opposite of gravity. So if this thing weighs 2 kilograms, force equals 2 kilograms times 9.8, because we said the force of gravity, or the acceleration due to gravity, is 9.8, and that's 19.6 newtons. So what we want to say is for every force, there's an equal and opposite force. So if that brick has a force down of 19.6, the surface is pushing back up with that same force. I find, and this is called a normal force, I find this is one of the hardest things for students to understand. If you take your hand and you gently place it on the tabletop, it feels like the tabletop is pushing back on your hand. The harder you push, the harder it feels like the tabletop is pushing down, or pushing back, I should say. So the force of gravity is pushing down, the surface is pushing back. For every force in physics, there's an equal and opposite force, and we often call that a normal force. So the force of friction in this case would be the coefficient of friction, how sticky the surface is, times the normal force, which is opposite to the force of gravity. 0.6 times 19.6, 0.6 times 19.6 equals 11.6 newtons. What does this number tell us? It tells us to get that brick moving, we need to exert a force, or we have to overcome a force of 11.76 newtons. Now, the second type of question you can get is to say, what is the coefficient of friction of a substance? So the coefficient of friction of a substance is the force of friction divided by the normal force. So if we said a force of friction is 10 newtons, and we said that it weighed 1 kilogram, so it's a hockey puck, so I'll draw my hockey puck. So it weighs 1 kilogram times 9.8 is a force of gravity of 9.8 newtons. That means that the normal force is opposite to that, that's 9.8 newtons. So it's going to be 10 divided by 9.8, which is going to be 1.02. This is a very high coefficient of friction. This would never happen for a hockey puck. You'd expect it to be down about 0.1 to 0.2, especially if it was on the ice surface. Folks, I would highly suggest that you look at these calculations a couple of times and that you write them out. And also go over all of that background information. Make sure you have good notes. Remember that your quizzes and tests are open book. That's lesson 1 for the day. Lesson 2 will come around shortly.